All right, so I just wanted to kind of talk more about this scope thing right here in the debugger, and I think a way that I can do that is by writing another example. This is gonna be a contrived example, more contrived than our previous one. So example 20, we'll do a function example 20. It's really not going to do anything particularly interesting, and we'll do function inner1. We'll declare a variable up here. Var a, or just a equals 20. And then inner1, we'll call that from here. And then in inner1, we'll do var b equals 30. And we'll call inner2. And then we'll write inner2. And then, well, actually, a better way to do this would be to return inner1, then return inner2. Then we'll do c equals 40. And finally, all the way at the end of this, we'll return a closure. And we'll do console log A, B, C. And then what I'm going to do is I'm going to run example 20 and say var closure equals example 20. Then I'm going to invoke it. So we do that, and we see 20, 30, 40. So we see that lexically we have access to A, B, and C. And if I went ahead and added a breakpoint right here in this closure, this final callback, and I invoked it, so that's just invoking closure. Remember, this is a global variable, so I can access it from my console. You'll see that the scope does have a closure on every single one of its inner functions. So the memory that was allocated, oh, come on. The memory that was allocated when I invoked example 20, which contains the variable a, is still in existence because it's been captured by this final closure that was returned. And so we see that closure example 20 has a of 20. And then our closure B, our inner 1, was captured, and our inner 2 was captured, and then our local is what is the scope that's inside right here, inside of this function expression. So we see there's this hierarchy of closures, and that memory will stick around. So what you have to remember is that every time you call a function, a new block of memory is allocated for the local variables of that function. And if any inner function refers to those variables will be captured. And if you eventually return a function that closes over any of those variables, all three of these scopes that were created, or all four of these scopes, we have a scope here, 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 still sticks around in memory. And it's actually captured by this actual closure object. So we can actually see that if I go ahead and resume, take off the breakpoint. Let's say I wanted to inspect something. What do I want to inspect? I want to inspect window. So if we open up window, we should have our closure variable here somewhere. And I do believe that Chrome is actually going to show me the memory that was captured. So all I need to do is find closure, which I can spell, I swear. Or no, it's sorting it differently. I should just be able to type in closure and get that. Derp. There we go, closure, and it's not going to give me, unfortunately, the memory that's captured, but there is memory that is captured inside of this variable, and that memory is basically all the memory that was allocated by invoking all these functions together. Actually, we should be able to... So the console, unfortunately, is printing out closure. It's not letting me inspect it, but I should be able to go over to the watch tab and hit add and type in closure, which, remember, is this object right here. Now, it is a function, but look at this. If I open up this closure and inspect it, this is what Chrome actually internally knows about this particular variable. It has arguments, caller, length, name, prototype, proto. We'll be talking about those later. But then it also has this function scope variable. And this function scope variable contains these three objects, closure, A, B, and C. Now, if I created another closure, then another whole function scope will be created as well in memory. So, yeah. With that out of the way, what I want to do now is I want to solve our original problem. So let's go ahead and remind ourselves what that original code was. So I'm going to close out of everything, go back into the console tab, I guess. I'm going to scroll all the way to the top, to the thing we started with in this entire series. And I'm going to go ahead and I'll uncomment it out for a second so we can see, we can remind ourselves of what the problem is. And remember, so what we're doing is we're looping through an array of strings. We're creating a new li element for each item in the array. We're adding a click handler. We have a closure right here. We have a function expression, and we are trying to grab the person variable from the parent scope. So remember, if I click on Nelson, it says you clicked on Baz at index 4. Well, for everything, it'll say you clicked on Baz at index 4. Now, hopefully, this behavior is starting to make a little sense, because ask yourself, what scope are we in? This function is a closure, but what scope is he inheriting? What's the scope above this? I can give you a hint. Let's open up our debugger and check it out. Go to sources, scroll up to the top. Let's put a breakpoint on our click handler, and let's click on something. And let's look at the scope. Look at this. We have local. Okay, so we have our local scope, which is the scope that was created by this function, and it has a this, and again, we're talking about this later. But then look immediately above it. It goes from local to global. And if we open up the global scope, this is our global scope. This is our window object. And that should make sense now, because if we look at our loop, we're using var, of course, but remember, we're not in a function. Because we're not in a function, this var is creating global variables attached to our window. So then when I add this event listener, it is being statically bound. When I do you clicked on person at index I, both of these variables are being statically bound to the person variable. But this person variable is not being recreated every instance of the loop. Remember, because of hoisting, this var person is being attached to the global scope. Meaning, it's not creating a new var person every time it iterates the loop, it's using the old var person. There's only one variable called person, and it's on the global scope, and whenever we do person equals people I, it's setting that one variable, that one variable that exists, to that value. So then, even though I'm capturing that variable in this closure, what I'm capturing is not a block scope variable. What I'm capturing is a variable that is attached to the window object, because there's only one. So let's talk about how to resolve this. And I want you, there's a handful of solutions that I want to demonstrate. And I want you guys to keep in mind, remember everything we've talked about so far, but especially remember that variables are scoped statically. Remember that we create scopes with functions, and remember that closures can capture variables. So I'm going to comment this example one out. And I'm going to scroll to the bottom here. And I'm going to do example 21, which I'm going to name solution 1. Okay, so what's one way to fix this? Well, one way to fix this is I'll do var people equals Nelson foo bar Baz. Actually, I'm going to move this above this example, and I'm going to put a separator here, and I'm going to do solutions to example 1, because this code right here at the top is going to be the same for everything. Then I'll say var list equals document get element by ID people list. Okay, so what's one way to solve this problem? The simplest way to solve this problem would be to use a new function. Remember, functions create scopes. So I'm going to say for var equals I, or for var blah, 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 you know what I'm saying. I smaller than people.length, I plus plus, and then I'm going to say var person equals people at I, and then I'm going to say var element equals document create element, not create attribute, create element, li, and then I'm going to write a function that we haven't declared yet. Prepare element for person, passing in our person and our element, and then I'm going to say list dot append child element. Now I'm going to write my prepare element for person, function prepare element for person that takes in a person and an element, and this is simply going to say element.inner text equals person, and then element add event listener on click to be a function that will say alert you clicked on person. Go ahead and save that out. Now I click on Nelson, you clicked on Nelson. Click on bar, you clicked on bar. So what's going on here? Well, what's going on here is every time we call this function, we're creating a new scope. Okay? So every time the function is called, we're creating a new scope, and we're basically capturing these two parameters. And these two parameters, remember, parameters behave just like local variables. So they're attached to this. So we're copying person and element out into prepare element for person. And then we're using a closure not to get a reference to this variable, but to get a reference to this variable, which is a copy of this reference. So yeah, basically we're creating a scope and we're copying these local variables into these local variables. And these local variables are different. I can name these local variables whatever I want. So the person is this, and we'll just replace that, and the element is that. So the names of the variables are completely inconsequential. It still works. Because we're copying these local variables into these local variables. All right, let's look at another solution. We can also use an IFFY. An IFFY will have the exact same effect. So I can say for var I equals 0, I smaller than people, length. I should have just copied and pasted this, shouldn't I? Var person equals people at I. Var element equals document create element li. And then I'm going to say list append child element. So I can use an IFFY. But I'm going to do something a little sneaky here, though. So here's our IFFY, which we're creating a new scope. And then I'll say element.inner text equals person. And then I'll say element.addEventListener click is this function expression that says alert you clicked on person. So what do you think the output of this program is going to be? Think about this one. Now come over here and we'll click on foo. And look at that. You clicked on Baz. You clicked on Baz. So it was actually kind of a trick here. Just because we create an IFFY doesn't mean we create a new scope. But what we didn't do is we didn't copy these local variables into other local variables. So think about that. Although we do have an IFFY here, we have an entirely new scope. What is happening here is this reference to element is still referencing this variable, which is not what we want. Now we could do something like this: var element equals element. Var oh, that's going to be weird. We'll do var element or person2 equals person. And then instead of saying element inner text equals person, we'll say you clicked on person2. So what do you think the output of this is going to be? Let's hit Control S and find out. As you see, it now works. Because now, when this IFFY is executed, immediately, because it's an IFFY, so this line of code will immediately be invoked, right? And because of that, because it'll be immediately invoked, we get a new local variable that is bound to this closure. So this is a closure, and a new variable bound to that scope, and we copied it out from the external scope. And then in this closure, we bound ourselves to the variable that was bound to this closure, and this closure gets created this IFFY gets created every time the loop iterates. Every time the loop iterates, we get a new instance of the scope. So what do you think the output of if I did person equals person? What do you think this would be? So you'll notice, actually that kind of gave it away. We get undefined, 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 and if I click, it says you clicked on undefined. Remember, that's because of hoisting. When I say var person equals the second I say var person, this closure has a local variable called person in it. So when I say var person equals person, this person is now bound to being undefined. See, when I use Visual Studio Code to try to highlight all the references to this, it picks up on that. It knows that by creating this var person, it's being hoisted to the top, and this person, even though it's right here just next to that var, it's still referencing an undefined variable. And because it's referencing an undefined variable, then we'll have a problem. So that is why we have to use a different variable name. But what if I really, really, really wanted to use the person variable name? Well, I can use a parameter. I can have this IFFY taking a parameter, and then I can pass it in immediately as an argument. And now, this person, if I click on this, notice how Visual Studio Code is correctly identifying that this person exists in this scope, and it's different than this person in that scope. Now you'll notice that the code still works. Now, I want to point out, I'm not doing element. I'm not capturing element, although I certainly could. I could write this. The reason is capturing element would be unnecessary because the only time we reference element is within the execution of this loop, whereas we reference person in a callback that is invoked at a different time in the execution. All right, so let's look at another solution. Last solution we'll look at in this video. So solution 3. This is going to be, I'm going to write a function. I'm going to write a function. It's going to be called for each array callback. And I'm going to say for var I equals 0, I smaller than array dot length I plus plus. And then I'm going to say callback, and I'm going to pass in array at I. Now, this is a more functional solution. This, let's just see it work first. So we'll do for each. Remember, we still have our people array at the top. So for each people, function person. And now we can say var element equals document create element, li, element dot inner text equals person, element add event listener click function alert. You clicked on person, and then finally list append child element. Hit Control S, and you'll notice it indeed works. Why does this work? Why does this work? So this is a more generalization. This is pretty much a complete generalization of this pattern right here, but it looks a whole lot better. That IFFY up there, I know that you have to do this sometimes, but I always find that syntax a little ugly in the middle of a loop. I always like finding a different solution. In fact, I would first prefer this solution. My second preferred solution would be this. And then finally, if you really, really have to, I would go with stuffing an IFFY in a loop. But this works because we generalize the whole concept. Every time we call callback, remember, every time you call a function, you create a new scope. Not the static type. You create a location, a block of memory where that function's local variables live. So every time we invoke callback, which is this function right here, every time we invoke this expression, we get a new block of data. And that block of data, it contains a copy of whatever was passed into this callback. And of course I can see that. I can pop open my debugger, go down here, blah, 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 click on this, then click on foo. And if I look at scope, I have my local scope. And then I have my closure, which is undefined. It doesn't have a name. And the closure is closed over on the variable foo. It's a copy of that. So every single one of these callbacks, every time that this got invoked, every one of these copies of this scope are getting a reference to a different person object because this callback was invoked multiple times. Now, for the sake of completeness, there is a built-in for each function. I just wanted to show you the implementation of for each, but I could have easily have written this as people dot for each and then passing in a function. And this will also work. This for each method is a little bit more complicated. The callback gets the value, the index, and the full array as the arguments. Of course, we only need the element here, but it's basically equivalent to if I were to have written my for each as that is basically the equivalent of what the built-in for each does. So that's an advantage of using for each, and that might be a source of confusion why sometimes you might have built a list of elements with callbacks with the for loop and you were confused like, oh, why isn't it working? But then you switch over to the for each method where you pass in a callback, and then suddenly it works. And that's because every time you call a function, a new block of memory is allocated for that function's scope. It actually gets a little bit more complicated. There are different terms for the runtime scope versus the lexical scope and all that fun stuff, but I don't really want to get into those terms because it might confuse things a little bit more. But anyway, those are closures. Now, in the next video, we're going to look at one final solution to this problem. Actually, that's going to be my preferred solution. But, yeah, these are closures, and Well, in this case, the only closure we really have is this right here, because it is closing over the person variable from its parent scope. But still, stuff and things. I hope that that helped you guys with understanding callbacks and more functional approaches to writing JavaScript. And we'll see you guys in the next video.